Hi there, this is Guided Practice 2. So we are looking at some practice problems here to go through for our limits. And we are going to try to do this using our shortcut method. So our first rule of thumb here is to always try plugging in our A value. And if that works, then great, we're done. If it doesn't, then we're going to have to see whether we're in a 0 over 0 case or in a number divided by 0 case. So let's take a look. Number one, we have the limit as x goes to 3 of -2, right? Now, -2 is the whole function. So if I plug a 3 in, there's nowhere to plug it in. So when I plug it in, it's just -2, right? The function is -2 all the time. And because I got a number that works, -2 is great as an answer, then I'm done, right? So my answer is just -2, okay? Next one. So let's go ahead and plug in our A value. So this is going to be 5 over 15 minus 1, so 5 over 14. And that's a perfectly fine answer. Nothing wrong with 5 over 14. So that's my final answer. Okay, so when I can plug it in, I just do. When I get to number 3, what happens? Okay, so here we go. We're going to have 1 squared is 1, minus 1. And on the bottom, I have 1 squared is 1, plus 1 minus 2. 1 minus 1 is 0 in the numerator. 1 plus 1 is 2, minus 2 is 0 in the denominator. So now I'm getting this 0 over 0 case. And we know that 0 over 0 is an indeterminate form. And so that means that my answer could be anything, depending on what's going on here. And what we want to do is to go ahead and do more work. And when we see that it's a polynomial divided by a polynomial, then the work that I want to do is factor. So this tells me do more work. And the work that we're going to do here is to factor. Okay. So if we try to factor this, this becomes the limit. Keep your good notation. And then the numerator, they both have an x. So I'm going to pull that out. So this is x times x minus 1. And then in the bottom, again, this should have an x minus 1 in it so that I can cancel it, so that I can use that to help me. But I'm looking for two numbers that multiply to -2 and add to +1. So we're multiplying to the -2, adding to the +1. And so that's going to be +2 and -1. So x minus 1 and x plus 2. Now that I have it factored, I can go ahead and cancel the x minus 1s. And I'll be left with the limit as x goes to 1 of x over x plus 2. Now that I've gone ahead and canceled and simplified, I can go ahead and evaluate my limit again. So let's try plugging in our limit one more time. So 1 on top and 1 plus 2 on the bottom, and I get 1/3 as an answer here. Okay. All right, on to number 4. Number 4, we plug in our 4, and when we do that, we get an 8. No, we don't. We get a 16 up top. And when we plug in on the bottom, that's 8 minus 8, so we get 16 over 0. Now, this is a different case. This is not an indeterminate form because it's not 0 over 0. It's a non-zero number divided by 0. When that happens, this is always an asymptote. And when it's an asymptote, we need to find out, are we going to positive or negative infinity on both sides? So we're going to check a value on either side of 4. So I'm going to go with f of 3 and f of 5. If I plug in 3, that's going to be 12 over 6 minus 8. That's 12 over -2, so that's -6. And again, the number part is not important here, mainly the sign. And so what that tells me, by the way, is that the limit as x goes to 4 from the left of your function is going to be -infinity. When we plug in 5, we get 20 over 10 minus 8. So 20 over 2 is +10. And again, I just write the plus for emphasis. This tells us that the limit as x goes to 4 from the right of your function is +infinity. And when these two things have opposite signs, or really these two things have opposite signs, we know that this is not going to exist. So our limit as x goes to 4 of 4x over 2x minus 8 does not exist. And that's my final answer on that one. Okay. Now for number 5, and our last one on the guided practice, this is a piecewise function. And so we looked at these in terms of graphs, but we never looked at these in terms of plugging in values, okay? So when your limit, right, and our limit being asked about here is as x goes to -1, and that corresponds to the point at which my piecewise function breaks into pieces. So the question here is, do these pieces kind of match up, okay? And one of many things can happen here, but what we want to do is when it's defined differently on either side, which it is, because we have x is less than 1 and x is greater than -1, then we want to look at the two one-sided limits. So we're going to look at the limit as x goes to -1 from the right of your g of x. And on the right side of -1 are the numbers that are bigger than -1. So in this case, we're going to be looking at this middle piece, right? Because that's when x is greater than -1. And so we're looking for the limit as x goes to -1 of the 3x squared plus 1, right? We're still looking at it from the right. If I then plug in my -1 to that piece, this becomes 3 times 1 plus 1 gives you 4. Okay, so plug it in there, right? The steps would look like this. 3 times -1 squared plus 1 is going to give me 4. Then we go ahead and look at the limit as x goes to -1 from the left of my function. And when I look at the pieces, to the left of my function is, to the left of -1 is when it's less than -1. So now we're looking at this blue piece here at the top, the 2x plus 7. So we want the limit as x goes to -1 from the left of 2x plus 7. And so we can go ahead and plug in our -1. So that's going to be 2 times -1 plus 7, and it looks like I get 5. Okay. And now I see what happens, right? So my limit from this one side is 4, but from the other side is 5, and those don't match. And so when they don't match, we get the limit as x goes to -1 of g of x does not exist. Okay, and that's my final answer. If they did turn out to be the same, then that would be my limit. Okay, but they didn't.